The SureServo2 platform offers many options for application flexibility. Many of the modes are position-based. However, the drive offers an option to run the motor at a specified torque up to a preset speed limit. The application possibilities for this mode are large. Perhaps you need to screw a bottle cap to a specified torque, or run a precision unwinder to torsion highly sensitive material to a very specific torque value. These are just some of the many times that a precision servo will greatly outperform a traditional VFD and motor. So let's take a look at torque mode in the SureServo2 today. This torque mode video set will have two parts. The first part will be an overview of torque mode and the system setup work. In the second part, we will get down to actually demonstrating torque mode on a motion system. For SureServo2, think of torque mode like a shoving match. If I'm walking forwards and there is no one across from me, I will keep moving at my desired speed until I run into someone. If they push against me only slightly, I will keep on walking and push them with me. It might be at the same speed or it might be at a reduced speed, but we will keep moving in the direction I want to go. If they push against me as hard as I push against them, we will come to a standstill and stop moving until either I push harder or they push less. Torque mode works exactly like this. We set a speed limit in the drive, and we set a desired torque set point in units of motor current. The drive will move the motor towards that torque set point. If it reaches the speed limit before hitting the torque value, it will maintain that speed indefinitely, even though the torque set point is not yet reached. If it reaches the torque set point before hitting that speed, it will hold that torque to the best of its ability. If the force required to drive the load increases or decreases, the drive will continue to target that same torque value, so the motor speed will vary as needed. As this drive has a 3.1 kHz bandwidth, it responds to changes in force extremely quickly, leading to reliable torque production even in the most challenging applications. If you are familiar with SureServo2 speed mode, it works similarly, but in reverse. You have speed set points and torque limits, with very fast control adjustments possible due to the drive's high bandwidth. For torque mode, there is a lot of customization and fine-tuning possible, with various advanced parameters. We will only be covering the basic settings in this video, so please refer to the manual for fine-tuning this mode for your specific application. For our application, we will set up a small belt-driven motion base driven by a 200-watt SureServo2 motor. To help further with a visual of torque mode function, I have a few weights that I will be placing on the motion base to increase the torque seen by the motor. Because our lead screw actuators, and even this belt-driven actuator, give great mechanical advantage in linear motion, I had to actually rig this motion system vertically to get gravity to give me a hand. When I tried this horizontally, the system was so efficient that the motor saw effectively zero torque difference between 1 kilogram and 5 kilograms of weight. As a slight disclaimer, this isn't a normal torque style application, but it will help highlight how the mode functions. If you do have a vertical lift application, take a look at the gantry option in the SureServo2. I also have a pretty cool little breadboard that my engineers procured for me. It allows control of all the drive's digital and analog inputs. For your application, you will need to build something like this, or use traditional digital inputs such as push buttons or selectors. If you have a Click, Productivity, or BRX PLC, they have simulator modules that would work perfectly for this function as well. For parameter settings, we will be using the software as we have throughout this SureServo2 series. We do this because the software is excellent and much easier to use for parameter changes than the keypad on these drives. The keypad is great for live feedback information, but it's inefficient for a large number of parameter changes. To start, let's reset our drive to default parameters so you and I can start at exactly the same place. By default, digital input, or DI1, is set to servo on, drive enable function. So let's make sure it's off so the drive isn't enabled. There are several ways to check the digital input status, but the easiest is to connect to the drive with the software, as I have done here, and go to the Digital I/O/Jog Control tab at the top of the window. We see that the servo on input is off, so the servo is disabled. We can then go in the software to parameter 2.008 and set it to a value of 10, which will reset the drive to factory default after a power cycle. Make sure and send the edit to the drive, then we power cycle. We also need to disconnect the USB cable from the drive since we aren't using the isolator, and the USB 5V power will keep the drive CPU on. It's a great feature for benchtop testing and initial configuration, but will prevent a power cycle if you aren't paying attention. Once we power back up and reconnect the cable, we can go online with the drive and read the servo parameters. I'm going to speed up the video for a moment, as it does take a bit to get all those parameters uploaded. Now that we are at the default settings, let's discuss the mode we will use. There are 2 dedicated torque control modes and several multi-modes that allow torque mode along with another. We won't cover multi-modes here, so let's take a look at our 2 torque modes. They are called T and T sub Z. In both modes, we can select up to 3 different predefined torque set points using torque selection digital inputs. If we don't select any of these, the mode will determine our torque. In the T mode with the torque selection inputs off, it will reference the -10 to +10 volt DC analog signal on the TREF terminal of the drive I/O. In the T sub Z mode, we will select 0 torque if we have the selection inputs off. If you aren't planning to connect something to the TREF terminal on your drive, ensure you use T sub Z to prevent unintended torque output or motion. There may be floating voltage on the terminal when there is no wire connected. Our speed limit in torque mode works similarly. We can use the maximum speed limit parameter, P1.055, to limit our speed, or we can enable a speed limit and use the VREF analog terminal on the drive and preset speed parameters selected with digital inputs. By default, the system will use P1.055 as the maximum allowable motor speed, which defaults to 6,300 RPM for our motor. Since that is faster than we want for this application, we need to enable a different speed limit. We will set P1.002 to a 1 to override the maximum speed set point in P1.055. This will allow P1.040 to determine our maximum analog speed, and we can use the SPD setting for the digital inputs to select our preset speeds. For our application, let's use T sub 0 mode, so we have a 0 torque base. We need to set P1.001 to a 5, but to do so we need the servo off, so we will again use the software to verify that DI1 is still off. And it is. We can then go to the parameters and set P1.001 to a 5 and send it to the drive. As this is a mode change, the software tells us we need to cycle power. We will do that once our other parameters are set. P1.002 needs to be a 1 to allow us to select our desired speed limit with the digital inputs. We will also set our torque set points and our speed limits. Starting in P1.009, we will set the first speed, and we want a slow, a medium, and a fast speed for this. These registers are set in tenths of an RPM, so let's try 100 for P1.009, 200 for 1.010, and 300 for 1.011. This will give us motion speeds of 10, 20, and 30 RPM. I'm also going to limit maximum motor speed in both P1.040 and P1.055 to 100 RPM for safety. It is important for you to run some theoretical calculations for your preset speeds. The maximum speed in P1.055 and the maximum VREF input speed, which is set in P1.040. The larger servos in the SureServo2 family are very powerful, and running them at default maximum motor speed without any forethought is a great way to destroy equipment. As always, ensure you have an emergency stop wired in as well to deal with any unexpected situation that might arise. For our torque settings, I have done some previous testing to figure out what works for the motion actuator we have in this example. So I will be using P1.012 set to a 65. We can leave P1.013 and 1.014 at the default of 100, as we will only need 65% and maximum torque in our example. These parameters are in percentage of motor rated torque. Your application will have its own torque set points that will require some engineering analysis and experimentation to establish. Finally, I want to be able to see what the motor's actual torque output is in real time. We can do this in several ways, such as the scope in the software. However, I will keep it simple and just set the LCD keypad to display torque value. We can change the information on the LCD display by altering P0.002. If we set it to a 54 for torque feedback, then we will be able to see the actual motor torque percentage in real time. Now we can update our digital input configuration. We know we will be using the T sub Z mode, so we will need some torque set point selections and speed limit selections, as well as a servo enable input. We will also want to be able to reverse our direction of travel. By default, as we see here, digital input 1 is set to servo on. This is our enable, so we will leave it alone. DI2 is set to pulse clear, and as we aren't using a pulse mode, we won't need this. To update this to something else, we check the box here for Edit DI/O item, and it changes all our digital inputs and outputs to drop-down selectors. We can click on DI2, and in the drop-down we can select 0x06, reverse direction of input command. We want this to be a normally open input, so we will leave the radio button to the right as logic A, and we must click OK to send the edit to the drive. If you change this information and click off of it without clicking OK, it will revert back to the previous setting. This is a very common mistake, so please watch out for it. The next two DIs are the internal torque command selectors. They work together to form a binary word. If both inputs are off, the drive will use the default torque command source, which in the case of T0 mode is 0 torque. If only the first input is on, internal torque command 1 is used, which we set to 65%. If only the second is on, it will be internal torque command 2, which is the default of 100 for us. And if both are on, it will select internal torque command 3, which we also left at the default of 100% of motor rated torque. DI 5 through 8 default to an alarm reset, reverse and forward overtravels, and an override stop. In a real-world application, we would likely need all of these functions. That leaves DI 9 and DI 10, our last two real-world digital inputs. We will use these to select our internal speed limit by setting them to 0x14 and 15, and using logic A for both. These two inputs are paired exactly like the internal torque command set points and form a binary word to select the speed limit during movement in torque mode. It is also important to note that if you need more digital inputs, you can use the virtual digital inputs as well, but they can only be commanded from the software or over a communication interface such as Modbus or Ethernet IP. Let's also uncheck the Edit DI/O item box to prevent any further unintentional changes. As we have done a mode change, we will also need to power cycle a drive. Again, make sure that the drive CPU isn't powered up by the USB cable and cycle power. Once the power comes back up, we can reconnect the software with the drive and read the drive parameters. Again, I'll speed up the parameter read. Now let's verify our changes are there. P1.001 is a 5, 1.002 is a 1, 1.009 is 100, 10 is 200, and 11 is 300. 1.012 is 65%, and 13 and 14 are both 100%. Our maximum speeds in P1.040 and 1.055 are both 100 RPM. Let's also make sure our LCD screen is displaying correctly by verifying that P0.002 is still 54. And it is. Perfect. We could verify all of our digital inputs here on the parameters screen as well, but it's easier on the digital IO/jog control screen, so let's go there instead. We see DI1 is servo on, DI2 is reverse direction, 3 and 4 are our torque selectors, 5 through 8 are the reset, overtravels, and override stop, and DI9 and 10 are our speed selectors. Perfect. Everything's set up, and the system is ready for some testing. For further questions, please contact our award-winning free technical support. To see the second part of this video series, click here. To take a look at our SureServo2 lineup, click here. To see more awesome videos from Automation Direct, subscribe to our YouTube channel here.